molecule looking for love, we have a solution for you. Take it from me, Mr. Bond himself. We have a website. Whether you're a dipole-dipole force, whether you're more into ion-ion attractions, maybe even hydrogen bonds, we have plans for each type. If you want to learn more, why don't you check out KeepYourIONme.net. We're accepting of all intermolecular types. Yes, even dispersion forces. So if you want to know more, visit that website, KeepYourIONme.net. So let's talk about our first intermolecular force plan, the ion-ion attractions. If you want to be the strongest out there, I'm talking about 400 to 4,000 kilojoules, this is the plan for you. Famous molecule NaCl is one of these. So if you're an ion, you're looking for this is what I would recommend for you. But we still have more coming up next. If that's not really what you like, that's okay. Our other plan, hydrogen bonding, is a special type of force. See, you can only be an N molecule, nitrogen, oxygen, or fluorine bonded to a hydrogen. The famous molecule of water is one of these. So if you're feeling like a little bit special and you're one of those molecules, it's definitely something I'd recommend. It's also one of the strongest intermolecular forces out there. But if that's not for you either, don't worry, we still have a ton more. So let's get into our dipole-dipole forces. If you're a polar molecule, you are eligible for our dipole-dipole force plan. Now, what is a dipole-dipole force? Dipole-dipole force is when a molecule at the positive or negative end binds to either the positive or negative end of another molecule. So what does that mean? Well, more specifically, if you're a positive molecule, you are binding to the negative end of another molecule and creating that dipole-dipole force. These are still stronger than London forces or dispersion forces, but it's not as strong as some of the other force plans that we've talked about. Some famous examples of this type of force could be HF or HCl, hydrochloric acid. Now, if you are a dispersion force or non-polar, we still have more to talk about. Before we talk about dispersion forces, though, we need to talk about the kind of underground ion dipole forces. A famous example of this is salt water, because you have an ionic salt, NaCl, with polar water. These are kind of more commonly found in solutions, of course, because it's what happens when you dissolve a solute within a solution, usually polar like water, because of that dipole force. But now let's finally talk about our dispersion forces for our non-polar friends. Finally, we have our dispersion force plan. Now, of course, this is the weakest force plan, dependent on the weight of the molecule, of course, just like every other molecule. If you're heavier, your forces are stronger. Just the same for this. These forces are also known by others as van der Waals forces or London forces, like we said earlier. Now, how does this affect boiling point, knowing that it's the lowest in energy force? Well, forces with higher intermolecular energies will have a higher boiling point because it will be harder to break apart those bonds. But if you just have dispersion forces, you're going to be more likely to have a higher boiling point. So, with that said, thank you for watching, and go to KeepYourIONme.net.